Pale blue dot. A vision of the human future in space. Carl Sagan. A vision of the human future in space. Pale blue dot. Chapter 5. Is there intelligent life on Earth? They journeyed a long time and found nothing. At length, they discerned a small light, which was the Earth, but they could not find the smallest reason to suspect that we and our fellow citizens of this globe have the honor to exist. Voltaire. Micromegas. A philosophical history. 1756. There are places in and around our great cities, where the natural world has all but disappeared. You can make our street and sidewalks, autos, parking garage, advertise, billboards, monument of glass and steel, but not a tree or a blade of grass, or any animal beside, of course, the humans. There are lots of humans. Only when you look straight up through the skyscraper canons can you make out a star or a patch of blue, reminder of what was there long before humans came to be. But the bright lights of the big cities bleach out the stars, and even the patch of blue is sometimes gone, tinted brown by industrial technology. It's not hard going to work every day in such a place to be impressed with ourselves, how we've transformed us for our benefit and convenience. For a few hundred miles up and down, there are no humans, apart from a thin film of life at the very surface of the earth, an occasional interfered spacecraft, and some radio static. Our impact on the universe is nil. It knows nothing of us. You are an alien explorer entertaining the solar system after a long journey through the blankness of interstellar space. You examine the planet of this humdrum star from afar, a pretty hamper. Some gray, some blue, some red, some yellow. You are interested in what kind of a world these are, whether their environment are static or changing, and especially whether there are life and intelligence. You have no prior knowledge of the earth. You've just discovered its existence. There's a galactic acid. Let's imagine. Look but don't touch. You can fly by these walls. You can orbit them, but you are strictly forbidden to land. Under such constraints, can you figure out what the Earth's environment is like and whether anyone lives there? As you approach, your first impression of the whole Earth is a white cloud, white polar caps, brown continents, and some bluish substance that covers two-thirds of the surface. When you take the temperature of this world from the infrared radiation it emits, you find that most latitudes are above the freezing point of water, while the polar caps are below freezing. Water is a very abundant material in the universe. Polar caps made of solid water would be reasonable gas, as well as clouds of solid and liquid water. You might also be tempted by the idea that the blue stuff is enormous quantities kilometers deep of liquid water. The suggestion is bizarre, though, at least as far as this solar system is concerned, because surface ocean of liquid water exists nowhere else. And you look in the visible and near-infrared spectrum for telltale signatures of chemistry composition, Search enough, you discover water ice in the polar caps and enough water vapor in the air to account for the clouds. This is also just the right amount that must exist because of evaporation if the oceans are in fact made of liquid water. The bizarre hypothesis is confirmed. The spectrometers further reveal that the air on this world is 1/5 oxygen. No other planet into solar system has anything close to so much oxygen. Where does it all come from? The intense ultraviolet light from the sun breaks water H2O down into oxygen and hydrogen. And hydrogen, the lightest gas, quickly escapes to space. This is a source of O2, certainly, but it doesn't easily account for so much oxygen. Another possibility is that ordinary visible light, which the sun powers out in the vast amount, is used to us to break water apart, except that there is no known way to do this without life. There would have to be plants, life form colored by a pigment that strongly absorbs visible light, that knows how to split the water molecule by saving up the energy of 2 protons of light, that retains the H and excretes the O, and then use the hydrogen thus liberated to synthesize organic molecules. The plants would have to be spread over much of the planet. All this is asking a lot. If you are a skeptical scientist, so much oxygen would not be proof of life, but it certainly might be case for suspicion. With all that oxygen, you are not surprised to discover ozone in the atmosphere because ultraviolet light makes ozone out of molecular oxygen. The ozone then absorbs the dangerous ultraviolet radiation, so if the oxygen is due to life, there's a curious sense in which life is protecting itself. But this life might be mere photosynthetic plant. A high level of intelligence is not implied. When you examine the continent more closely, you find there are, crudely speaking, two kinds of regions. One shows the spectrum of the ordinary rock and mineral and found on many worlds. The other reveals something unusual, a material covering vast area to strongly absorb the red light. The sun, of course, shines the light of all color with a peak in the yellow. This pigment might be just the agent needed if ordinary visible light is being used to break water apart and account for the oxygen in the air. It's another hint, this time a little stronger, of life. Not a bug here and there, but a planetary surface of overflowing with life. The pigment is in fact chlorophyll. It absorbs blue light as well as red, and is responsible for the fact that plants are green. What you are seeing is a densely vegetated planet. So the Earth is revealed to possess three properties unique at least in this solar system: ocean, oxygen, life. It's hard not to think they are related, the ocean being the site of origin and the oxygen of the product of abundant life. When you look carefully at the infrared spectrum of the Earth, you discover the minor constituents of the air. In addition to water vapor, there's carbon dioxide and methane and other gases that absorb the heat that the Earth tries to radiate away to space at night. These gases warm the planet. Without them, the Earth would everywhere be below the freezing point of water. You would discover this world's greenhouse effect. Methane and oxygen together in the same atmosphere is peculiar. The role of chemistry is very clear. In the excess of oxygen, methane should be entirely converted into water and CO2. The process so efficient that not a single molecule in all the Earth's atmosphere should be methane. Instead, you find that one out of every million molecules is methane in an immense discrepancy. What could it mean? The only possible explanation is that the methane is being injected into the Earth's atmosphere so quickly that its chemical reaction with oxygen can't keep pace. Where does all this methane come from? Maybe it ships out of the deep interior of the Earth, but quantitatively this doesn't seem to work, and Mars and Venus don't have anything like this much methane. The only alternative are biological, a conclusion that makes no assumptions about the chemistry of life or what life looks like, but follows merely from how unstable methane is in an oxygen atmosphere. In fact, the methane arises from such sources as bacteria in bogs, the cultivation of rice, the burning of vegetation, natural gas from oil wells, and bovine flatulence. In an oxygen atmosphere, methane is a sign of life. That the intermediate intestinal activities of cows should be detectable from interplanetary space is a little disconcerting, especially when so much of what we hold dear is not. But an alien scientist flying by the Earth would at this point be unable to detect bugs, rice, fire, oil, or cows, just life. All the sign of life that we've discussed so far is due to comparatively simple form. The methane in the rumens of the cow generated by bacteria that homestead there. Had your spacecraft flown by the Earth 100 million years ago, in the age of the dinosaur, and there was no human and no technology, you would still have seen oxygen and ozone, the chlorophyll pigment, and far too much methane. At present, though, your instruments are finding signs not just of life, but of the technology, something that couldn't possibly have been detected even 100 years ago. You are detecting a particular kind of radio wave emanating from us. Radio waves don't necessarily signify life and intelligence. Many natural processes generate them. You've already found radio emission from other, apparently uninhabited worlds generated by electrons trapped in the strong magnetic field of a planet, by chaotic motions at the shock front that separate its magnetic fields from the interplanetary magnetic field, and by lightning. Radio whistlers usually sweep from high note to low and then begin again. Some of these radio emissions are continuous, some comes in repetitive bursts, some last a few minutes and then disappear. But this is different. A portion in the radio transmission from us is just the frequencies. The radio waves begin to leak out of the planet ionosphere, the electrically charged region above the stratosphere that reflects and absorbs the radio waves. There is a constant central frequency for each transmission, added to which is a modulated signal, a complex sequence of ons and offs, no electrons in magnetic fields, no shock waves, no lightning discharge can generate something like this. Intelligent life seems to be the only possible explanation. Your conclusion that the radio transmission is due to technology on Earth holds no matter what the ons and offs mean. You don't have to decode the message to be sure it's your message. This signal is really, let us suppose, communication from the US Navy to its distant nuclear-armed submarines. So, as an alien explorer, you would know that at least one species on Earth has achieved radio technology. Which one is it? The beings that make methane? Those that generate oxygen? The ones whose pigment color the landscape green? was somebody else, somebody more subtle, someone not otherwise detectable to a spacecraft plummeting by. To search for this technological species, you might want to examine the Earth at finer and finer resolution, seeking, if not the being themselves, at least their artifact.